Good afternoon, ladies and gentlemen, sehr geehrte Damen und Herren, schön, dass Sie dabei sind. Welcome to this presentation. This is going to be a case study presentation. We are going to guide you through an interesting project that we did. It's going to be anonymized. We are not allowed to reveal the name of the client, but we believe that some of the findings will be relevant and hopefully of interest to you as well. My name is Carlo Giallombardo, and I have the pleasure to represent the process electrification practice of Schneider Electric. This is a consulting outfit with a global footprint. Our mission is to integrate a full set of Schneider Electric solutions. If you're familiar with Schneider Electric, you know we are quite wide as a business and have a lot of business lines and services and softwares and consulting. Consulting is a part of it that ties it all together. So that's what my team does. The focus is electrification, and to do it successfully, you need to start from process and power optimization, and this is exactly what this project is going to be about. Focus is in the raw materials segment. So let's get right in. Let's set the scene. So industry is somehow struggling to decarbonize. When we look specifically at the energy-intensive industries, we see that's a quarter of global emissions. And if we zoom in a little bit more and go into the raw materials, in the materials segment, that's about 15% of global emissions. So we're talking 7 gigatons of CO2 globally. That's quite sizable, so it's strategic to address this segment specifically. When we say struggle, what we mean here is these industries are doing their best to decarbonize already. There is a clear path for them. They are on it. But if we look at statistics, the decreasing trend of emissions is not there yet, meaning more needs to be done. And one way to achieve this is electrification. Again, if you look at the world in different segments, you will see that energy consumption by sector is split, and in light green you have the electricity, meaning that all the rest is other fuels, which predominantly means fossil fuels, obviously, lots of natural gas, coal, and whatnot. So in light green you see that there is an uptake in electrification already, and that's a positive sign, and some segments are more advanced than others. In many others there is plenty of opportunity to electrify more. The assumption here being that green electricity, green electrons, eventually will be predominantly low or zero carbon, something that for fossil fuels is almost unachievable. According to the IEA in 2024, 40% of new electricity demand came from electrification, so demand from industry for electrification. So there is a clear trend there, and we believe that there will be more of this coming up in the future as well. So when a company is wondering about their electrification plus potential, plus being the process and power analysis that you have to do to successfully electrify, there are plenty of elements that you need to take into account. And obviously, you need to start from the technology. And I think companies are very aware of what their technologies might be, if it's possible to electrify a specific process or not. But you cannot just stop there, because obviously if you want to go ahead and give these projects a green light, you will have to look at other factors. For example, economics. You will need to know whether the energy costs are right, whether the CO2 costs, or CO2 taxes rather, are beneficial and in your favor, and if there are any incentives or regulations that drive the industry your way so that you can put down these projects, which may be more expensive in some cases. You also need to look at the energy mix, so you want to figure out whether you want to go for a full electrification or maybe a hybrid solution. Effectively looking also at your energy management, so look at your process in greater detail. Again, this is part of an optimization that just makes sense, particularly for energy-intensive industries. And lastly, you want to make sure, if you want to electrify, that you have the right power supply, because you might be shifting from medium voltage to low voltage, and then you need to figure out if you can connect to the grid. Do you have an access point? What are the grid regulations? Can you expand? Is it desirable to do so? And also, what is the carbon intensity of the grid? Because in some cases, you might be switching to an electric grid that is higher carbon than the fuel you were originally using. So you need to be mindful of these type of solutions. Beyond decarbonization, you have a full host of elements that need to be taken into account, and this is exactly what my consulting team does. It's connecting to some other areas that are just as key. Energy efficiency is obviously one of them. We want to electrify processes. We do so at a cost. We want to make sure that energy usage is optimized as much as possible before moving to electrification, because otherwise it's just added cost that you don't want to face at that point. There is a topic about operational efficiency. By switching to more integrated, intelligent electric equipment, you might be able to have better control over it. Predictive maintenance might be a topic. You might be able to collect data streams that you were ignoring before, and so on. So a modernization and digitization component if you want. Better controls also improve safety and security. So you are optimizing maintenance as well, potentially. And most importantly, you might be looking to integrate your plant or process with renewables. So you might be thinking, okay, let's install PVs on site, or maybe we install a battery system, or in some industries they're thinking of hydrogen. How does that all fit into the energy balance of the plant? Can I integrate it? How can I take care of it? And last but not least, there is also the grid stability, how to connect to the grid. Can I sell some back to the grid? Can I partake in ancillary markets? Because that's a good business case to evaluate as well. So you see, there are plenty of elements that need to be taken into account well beyond that. And with this, I'm into the case study of the day. So this is a European example. I cannot specify where this is, but it is a metal refining plant. So we conducted an analysis here. The main target was reducing energy costs and also improving process productivity and safety. And with this project, we did find some important energy reduction opportunities. You can see specifically lightly above 20% reduction possible, and this was using an energy balance model that found some optimization in the melting process, so quite an interesting finding. And to optimize the electric process, we did use a digital twin to model the system and see how we could optimize it further. And I'm going to show you some of these results as we move along. When we run a project like this, we look at different models. So we do an analysis, and obviously we look at business as usual. That's the M0 that you see at the very top. This was a project running predominantly on natural gas. On the opposite side of the spectrum, you have M2, and that's a full electrification of process. And in between, we have the different models that we ran and the different energy conservation measures that we identified, if you want, and the different savings that they yield. So the most impactful one by far is Model 1A. This was about reducing air excess in combustion process. This immediately yielded about a saving of 20%. So quite a low-hanging opportunity, if you want, and quite an interesting one. But as you can see, we look at other opportunities as well, and 1B and 1C are additional energy conservation measures, and each has been assessed individually. And then in 1D, we are looking at the combined effort of 1A, 1B, and 1C all together, yielding for about maximizing at a 30% energy saving potential for this specific process. Of course, the full electrification has been assessed as well. This is ultimately what companies want to know today. Can I fully electrify, and if so, with what results? And they want to have that in one corner to benchmark whether that actually does make sense. And that's kind of an interesting finding. And if I go to the next slide, you will see what the results were in terms of OpEx. These are the bars that you see in green. And then also in terms of Scope 1 emissions, so ton of CO2, that's the orange dot. Again, starting from the left, business as usual, and then we are progressively moving through the other models all the way to the right. So 1A is the one immediately off from right, and there you can see that there is an OpEx reduction, but most importantly, quite a reduction in terms of CO2 emissions, thanks to this one intervention. When we look at the cumulative effect of the other interventions, you see that it becomes a little bit less interesting, meaning that it's less impactful, and that the combined effort would be quite relevant, but not as impactful all in all. Opposite case for the full electrification potential. So here we are on the far right. So there you can see that there is quite an increase in OpEx, very significant in fact, but of course a complete reduction of Scope 1 emissions, which drop to zero. Of course, these will translate to Scope 2 emissions unless you are able to source renewable electricity. In that case, it's effectively zero as well. But this is just a visual aid to see what the opportunities look like when you compare one to the other, how they match, and basically guide the client in terms of decision making for them to actually invest or not in a specific project. As a follow-up, we do a sort of process diagram or a flowchart if you want, and here we are comparing the different options. And this is now including a time factor, so most likely when it's not a greenfield eventually it's about doing different energy conservation measures over time, and you see how they stack. And here we elaborate on the different pathways, and it's interesting to note that between 2024 and 2038, in this hypothetical business case, you have a few stop points. That's the red points, effectively the nodes, if you want. And this is points in which you might do well to reevaluate what the electricity market is, if technology has advanced, because they're far in time. So, as is, you might pick one specific path, but perhaps something has changed, and you might want to have the flexibility to switch between one pathway or the other if the situation evolves over time. And then maybe lastly, you want to have like a full timeline of potential projects to implement. So you would need to maybe consider that one initiative is maybe not ripe because the plant is outfitted with equipment that is not yet fully discounted. So of course you could throw that away and electrify it, but most likely finance will not be happy about that decision. So ideally what you do is you look at the full program in time and you say, okay, this initiative might happen at a later stage. And maybe we will integrate and switch to fully electric kettles, but at some point in 2037, as is suggested here. But what you're looking at are the different measures, and for each we calculate the CapEx, the OpEx, the CO2 saving as impact, as it's defined here, and basically offer what a trajectory could look like. A roadmap of sorts, if you want, towards a full decarbonization. Since we know what the final objective is, what we are trying to do is clarify, okay, what will the path look like for this specific in this specific implementation, but for any company, really. Voila. So this is the trajectory that came out of this example. I don't think it's very important to see what the different items are. It's more interesting to see how you break them down over time. And of course, you will execute the projects that have best return on investment first and save the ones that have perhaps less attractive return on investment later in the day, in the hope that a new technology or maybe a new incentive system is in place for you to drive that change. And that was my presentation for today, so I thank you for this. There is a QR code if you're interested in the process electrification practice. If you follow the code, you'll be able to go to the webpage and see some other interesting projects that we have done. My focus is on Germany, Austria, Switzerland, and Italy, but we have some global projects. And thank you very much for bearing with me. It's been a pleasure to be here today.
Thank you.